Welcome back to my channel and welcome back to my virtual classroom. For today's video, we're gonna be discussing about Fibonacci numbers and of course the golden ratio. But for this moment, I'm gonna be concentrating more on Fibonacci numbers. Okay, so who was Fibonacci, by the way? So a famous mathematician, Fibonacci, is a short for the Latin Filius Bonacci, which means the son of Bonacci, but his full name was Leonardo Pisano. He introduced the Indo-Arabic number system in Europe. Okay, so origin of Fibonacci sequence. Fibonacci sequence was discovered after an investigation on the reproduction of rabbits. So Fibonacci rabbits, the problem is, suppose a newly born pair of rabbits, one male and one female, are put in a field. Rabbits are able to mate at the age of 1 month so that at the end of its second month, a female can produce another pair of rabbits. Suppose that the rabbits never die and that the female always produces one new pair, which is one male and one female every month from the second month on. How many pairs will there be in 1 year? So that is the question. So if you're going to look at it, so 12 months. Okay, so what is the answer for this? So at the end of its, let's illustrate. So at the end of the first month, there's still only one pair. So one pair. That's one male and one female. Okay, at the end of the second month, the female produces a new pair. So there are two pairs of rabbits now. So at the end of the third month, the original female produces a second pair, so making it three pairs all in the field. So this is the illustration. So at the end of the fourth month, the first pair produces yet another new pair, and the female born 2 months ago produces her first pair of rabbits, also making five pairs. Okay, so we're going to look at it. So that that particular pairing of rabbits form a specific sequence. Okay, so at the end of 1 year, there are 140 pairs. So thus we get the following sequence of numbers. So we have one, so 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. So this sequence in which each number is a sum of two previous is called Fibonacci sequence. So if you're going to look at the sequence, so 1, and then you add the previous number, 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8, and 5 plus 8 equals 13. 8 plus 13 equals 21. 13 plus 21 equals 34. And 21 plus 34 equals 55. 34 plus 55 equals 89. 55 plus 89 equals 144. So you can now determine the succeeding numbers. How? So just add the previous number. So this sequence is called Fibonacci sequence. So there is the simple rule. Just add the last two to get the next. So if you're going to add 89 plus 144, so what will be the number here? And you can do it, you can find the rest of the numbers. Okay, so that is Fibonacci sequence. Fibonacci sequence in nature. So spirals seen in the arrangement of seeds in the head of the sunflower number. So if you're going to look at the seeds of the sunflower, so let's zoom this in. Okay, so if you're going to look at the arrangement of the seeds, you see, so there's a particular sequence which follows the Fibonacci sequence. So spirals seen in the arrangement of seeds in the head of this sunflower number. So we have 34 in a counterclockwise direction. So if you're going to count it. Okay, so there. Okay, so there are 34 in a counterclockwise direction. And 55 in a counterclockwise direction. So that is the arrangement of the sunflower. So note that 34 and 55 are the ninth and the 10th Fibonacci numbers respectively. So pine cones also shows the Fibonacci spiral. Okay, so these pine cones. Okay, so if we're going to look at the arrangement, so you'll see that there is, okay, in a spiral form. So this is 1, ayan, and of course 2, 3, and so on and so forth. Okay, and also this one, so you'll see the sequence. Okay, so there is a particular number. Okay, so note that 8 and 13 are consecutive Fibonacci numbers. So 8 and 13 is Fibonacci number, are consecutive Fibonacci numbers. Okay, so what other Fibonacci sequences which you can find in nature? Okay, so the Fibonacci numbers can be found in also in pineapples and bananas. So bananas have 3 or 5 flat sides. Okay, and pineapple scales have Fibonacci spirals in sets of 8, 13, 21. So sets we're talking about sets. So if you're going, this is the illustration. Okay, so there are 5. This one is one set, so 5. And this one is 8. And this one is 13. So another set. So you can, if you can see, so again, Fibonacci sequence pa din yan. Okay, so much for this. So this is the introduction about the Fibonacci numbers in nature also. So I would like to um, also acknowledge the honor of some of the pictures that I use from the University of Mathematics. Okay, so it's Professor Isa. Okay, so that's it for this video. I hope to see you in another video talking about the golden ratio naman. Okay, so bye everyone.